Today, we will be interviewing Dr. Nick Jukes. Nick is the coordinator for InterNICHE, and we will be talking about replacing animal use in science and education. Thank you, Nick, for joining us today.
Thank you, too.
So my first question is something of a theoretical question, touching on a distinction that we've discussed in previous conversations. What is the difference between research, testing, education, and training? And why is this important from the standpoint of how animals are used in science?
Well, animals are used in a number of different ways. One area is education and training, in which there are animal experiments, the dissection of purpose-killed animals, and other instrumental animal use. And education and training is more of a pedagogical and a technical issue. It's about gaining knowledge and skills and positive attitudes towards animals and towards your profession. For example, medicine, veterinary medicine, and biology. And the animals may be used within practical classes according to different disciplines: anatomy, physiology, surgery, and so on. So it's a different issue. Education and training as one field is quite different to research and to testing. Research is about the finding of new knowledge. In education, you're looking at known knowledge and learning that afresh as a student. But in research, you're looking at finding new knowledge. And that's quite a different area. That's a scientific field. Testing itself is applied research, and that's how drugs or chemicals are tested for, supposedly for consumer safety and for their efficacy. So that's the applied research angle. This is usually due to regulatory requirements, which may or may not reflect the latest science. There's often a time lag with legislation and the innovations that can enhance the quality of science. But testing is the area where drugs and chemicals are tested for consumer safety, for efficacy, and that's quite different from research, but it is the applied angle of research. So these two are sort of science and technical issues, whereas education and training is the pedagogical and to some degree technical area.
And what areas does InterNICHE focus on?
So InterNICHE, as the International Network for Humane Education, focuses on education and training. It's important, I think, because it's how students of the life sciences will gain the knowledge and the skills and the attitudes which they will then take into the professions, how they become professional doctors and vets and biologists, working in the field, working in society. So while the numbers of animals used, conventionally used within education and training, are much lower than within research and testing, it's a very significant field because it's where critical thinking is developed, where someone's emotional and ethical literacy are maintained and developed, or to some degree damaged by harmful animal use. And it's where the knowledge and the skills that they'll be taking forward are learned. It's also where students may make choices about what profession they want to go into. So it's a very important area because it leads into science. So in our arguments, humane education and training feeds into a humane science, and it's an essential element of that trajectory, that the path from child to high school student, to university student, and then to professional. It's important that humane approaches, innovative approaches are employed throughout the whole of that journey. Otherwise, we end up with problems along the way and problems within the professions. So that's our area, education and training, but we're cognizant of how the impact of humane education and training will feed into the development of humane science, that is research and testing.
I believe you mentioned dissection, but in what other ways are animals commonly used in education and training?
So there's the dissection of purpose-killed animals, animals killed for the purpose of education. And that field that you mentioned is a major area. In some countries, such as the US, dissection is quite common in high school level, but in other countries, that might not be the case or might even be against the law. So there is a high school element, but the majority of animals used for dissection would be at university level by students of biology within their zoology course. And also veterinary students and some medical students might even be using animals too for dissection. So that's one area. The next is the animal experiment. So that's the use of the animal while he or she is alive or is freshly killed, and that tissue used within a preparation for a lesson in physiology or pharmacology. So animal experimentation is the second area. And of course, there you have challenges concerning the ongoing suffering of the animal, as well as questions about how effective the learning, the teaching is as well. Then there's also other instrumental animal use, which is neither dissection nor an animal experiment, but which also is might be harmful to the animals. So there's three sort of areas. Within research and testing, we're looking at primarily animal experimentation as one of the major methods. But it's important to recognize that there are a lot of changes happening with replacement of that harmful animal use. That's the term we use to cover all three of those areas of animal use that's harmful. And also that there are some humane traditions. So some countries, some disciplines, some individual universities might be by convention using humane methods. So there is some positive history, and there's a lot of positive progress at the moment with change being catalyzed by a number of different stakeholders and for a number of different reasons.
How much priority is currently given to animal welfare in science and education? Are there widely accepted standards of animal welfare, or is that something that's commonly disregarded by scientists and researchers and teachers?
There's a growing movement to teach animal welfare within veterinary education and training, for example, where people are learning about ways of recognizing stress and so on within individual animals. We would argue that there's not that many benefits to teaching animal welfare if animals are also being used in a harmful way. It will negate most of the lessons about animal welfare, about ethics, if you're also in the next practical class using animals in ways that are harmful. So it's important, I think, to be consistent and for animal welfare and ethics to be taught alongside the use of humane alternative methods, which we should argue should be full replacement methods. And there are plenty of different types of alternatives that can indeed meet teaching objectives, which is the main issue we're trying to achieve here. What are the teaching objectives and how best to meet them? At the same time, there are also the 3 R's, philosophical and practical approach developed in the late 50s and increasingly being implemented by institutions, both in education and training, but also within research and testing. And the 3 R's stand for replacement, reduction, and refinement of animal experiments. And the 3 R's are often introduced into legislation where teachers, or especially researchers and technicians, have a legal obligation to consider them. The challenge is whether or not they are genuinely considered, whether or not the researchers in the fields of research and testing have effectively searched for suitable alternatives, and that should be a global search. And so sometimes refinement is used as a way, refinement, for example, of a larger cage or more enrichment for the animals. Refinement might be used as a way of continuing the animal experiment whilst also reducing suffering to some degree. So it can be a way of continuing the practice rather than really solving the main issue, which is that animal experimentation is happening. But within the 3Rs, replacement should be prioritized within the original philosophy. Replacement is the end goal, is the main aim. And if that isn't being truly considered, then the 3Rs aren't being followed. And certainly, I think we can say that the 3Rs have brought about some replacement, but a lot of the 3Rs implementation has been that of reduction of the numbers of animals used in experiments and refinement of the technique and the potential for animal suffering. And that doesn't really solve the main issue. So it can become an excuse, it can become a rationalization, a justification for the animal experimentation to continue. So there are some challenges here within the 3Rs, but at least there has been some progress, and the more we can push for replacement and good quality replacement methods, the more we can, I think, both enhance education and training in the field I focus on, and also improve the quality of the research and the quality of the testing as well within the field of science.
So what are some of the alternative humane methods that you've mentioned, either well-established ones or ones that are very recent and cutting edge?
It's a combination really of humane traditional methods and well-established ones, plus the new innovations. Within education and training, there's a number of different types of alternatives. We could split them into two. One is the non-animal method, and the second would be working with animals in a way that actually benefits, or at least is neutral towards an individual animal. Looking at the first half of those, we have non-animal methods such as film and video, which can be digital video, which is very flexible. It's certainly not hands-on, but you don't always need to meet that requirement for hands-on experience. So film of recordings of a professionally performed dissection or of an animal experiment, which can directly replace it and provide the same teaching objectives when students participate in it. So film and video is one very simple method. It's been used for decades. Secondly, we have models and mannequins and simulators. Wooden and plastic models, many have been used again for decades, even centuries in some case, to help illustrate anatomy. You can have models that you can take apart, they've got labels, and these are very, very effective. We also have the more complex mannequins for skills training. So this is where a student, for example, of veterinary medicine or human medicine, although for human medicine, we can really strongly argue that no animals in any way, not even simulated animals, would be the best approach, because they should be focusing on human bodies and human physiology with human surgery. But for veterinary students, the mannequins can be used for practicing different clinical skills and surgical techniques, ranging from how to hold an animal to intubation, putting a tube down the throat, to a number of different surgical techniques. And these mannequins or some models allow students to practice a certain technique, develop their eye-hand coordination, their muscle memory, and to practice and practice and practice again, to learn through their mistakes. So this is something where you can see clearly that the alternatives actually offer something extra to the conventional animal experiment. You get a chance to keep on honing your technique, to develop that until you've really got that mastery. And certainly with veterinary students, you need to graduate as a master and then go straight into your practice. So it's very important that students have had the chance to have a lot of access to models and mannequins, from the very basic, like a suture pad, to practice how to hold a scalpel, how to have hold a needle, how to give an injection, how to do different sutures, different patterns, which are very, very simple models, but the level of fidelity, the level of realism is sufficient, because you're looking at a basic skill, which you just need to keep on practicing. And then those models and mannequins go right up to the very complex. And there's been some really great developments recently in materials science, where highly realistic organs and tissue have been developed, which is often better than working with a a cadaver or working with an animal experiment, because you have everything of the same color. It might have circulating blood and organs that work. You can practice all these a big range of different clinical skills and surgical scenarios, and you can introduce new situations. You can introduce emergencies within a sort of safe environment for the trainees. So it's often much more effective, as the published studies can demonstrate, in terms of knowledge and skills acquisition in this case, compared to the harmful animal use like the animal experiment. So the mannequins can be very, very effective for students to practice and practice and practice again. And then there's a whole range of other simulators where you can practice very specific techniques. So those are the sort of non-animal methods. The methods that might involve animals, but we would consider still to be alternatives, even though the ideal replacement alternative within the 3 R's approach is a non-animal method. Within education, we think the 3 R's needs to be somewhat refined. It needs to be focusing only on replacement because it's so feasible and desirable, but also that it is broadened to include approaches that involve animals, where the animal is not harmed in any way at all, may benefit. And this would include a body donation program of animal cadavers linked to a veterinary teaching hospital or an independent clinic, where, just like a human body donation program, the companion animal guardian, the pet owner, could donate the body of the animal after euthanasia. And this is the genuine meaning of euthanasia, where I'm talking about a mercy killing, where the animal has to be put down for medical reasons, so for the animal's own benefit. Those animals then could become ethically sourced animal cadavers and could be used for dissection when you really need that skill. Most students don't. A veterinary student will do. And also for some clinical skills and surgery practice. The other area where you have animals involved is within the clinic. So just as a medical student will be observing and assisting and performing minor procedures with human patients, the same happens to some degree within veterinary education and training. But we would argue that the earlier it starts, the more access students have. For example, contributing to spay-neuter programs, other sort of outreach where students have got the chance to participate once they've gained skills on the non-animal methods, once they've had sufficient training to be only benefiting the animal as well as learning for their own education. And of course, that the teaching hospitals can provide a major opportunity for this. So these are the sort of alternatives. You can also do simple physiology and pharmacology experiments on yourself as a student. And for medical students, that's the human body is the appropriate reference object. So that's a very important thing to remember. And of course, it's fun doing something on yourself. This isn't invasive work. This is something like exercise physiology. It's looking at drinking coffee and urine analysis. But these are all things that are part of the physiology and the pharmacology practical class. And then there's ethical field work. So students getting out of the lab into the field, observing wildlife, learning from wildlife, helping wildlife, getting involved in conservation biology projects. And again, this is also another area where replacement can be achieved and students can learn the same teaching objectives and more. So that's within education and training. Within research and testing, there are a lot of new methods being developed very rapidly. These include the sort of more information computational based approaches, whether it's comparing a new molecule with an existing molecule where the toxicity is already understood, and then being able to have a very good gauge of whether or not this new molecule may or may not be toxic. And this is all part of the screening process where new products, new chemicals, new drugs can be screened out as likely toxins. So this sort of approach is very valuable in terms of big data, in terms of using the power of computers to be able to number crunch and compare and analyze. And I think that's one very major area. Another one is the use of organs on a chip, including multi-organs on a chip, which, while they're not don't reflect the full human body, they certainly can help you look at toxicity, can also achieve the results that you're looking for much faster in terms of predictivity. Most animal organs on a chip and other approaches, yes.
What is that?
Organs on a chip is where you have a sort of material object with real tissue within it, and then you can analyze the mechanisms, you can follow the processes when a specific drug or chemical is added in order to help find out whether that is toxic or not. And predictivity is a very important area within testing, because you have a situation where over 90% of drugs fail at the clinical stage, raising major questions about all of the process leading up to that point. And the problem is that most of this old data is based on animals. So we have a challenge here in terms of how new methods can develop. And you also have a problem with patenting and non-sharing of information. So a lot of experiments are repeated, and a lot of companies working in competition with a lot of power and a lot of money are not sharing that information. So it's important, I think, to look at these new innovative methods, both in terms of their better predictivity, but also because something like a drug development and the testing can happen in a much faster way. It's a much more efficient method. And what was seen as the gold standard, the animal experiment, is people are realizing that actually, no, it was quite tarnished. It wasn't a gold standard at all. It's very hard to compare between species. Of course, there's some commonality, but there's a lot of difference. And with the new methods that are more human-based, using human tissue, culture, and organs on a chip, then you don't have that problem of extrapolation between species. Mm-hmm. So it's very, very effective in terms of better predictivity, and therefore better guarantees of consumer safety, of consumer health.
You've touched on this some already, but what are the drawbacks to traditional animal use in science and education from a human perspective? And then compared to that, what are the advantages that non-animal methods provide?
I think, as I've just said, with concerning testing for human drugs, you have a problem where the predictivity is not good enough with the animal experiments, that the development of drug might take 10 years and billions of dollars, whereas the alternative methods, which are increasingly being recognized as better science, and in fact, this realization, the scientific argument, is really pushing the process of acceptance of these new methods, these innovative new methods, and because of the better science. We have a situation, I think, where even now many of the regulatory bodies and the funding bodies from the National Institutes of Health in the US are coming out and saying there needs to be new approaches, a 21st century toxicology, rather than old methods that haven't really been validated themselves. So the process of validation of the alternatives, even that is a slow process, but the result is methods that can directly replace individual tests, and more broadly within research can provide more human relevant techniques and therefore results. So I think we have a problem there where not only is it a waste of money and a waste of time when animal experiments are used, but we can get better results with the alternatives, which are better suited for humans. Of course, you also need veterinary medicine, veterinary drugs. And for those, you need animal tissue, but that doesn't need to be an animal experiment either. It can be using ethically sourced tissue. It can be using the non-animal methods. And together, they can be more effective than the conventional methods. Of course, there's the animal suffering. There's also the animals being killed, the animals being experimented on, and the broader picture from disposal, as well as the actual killing and experimentation itself. So that has broader ecological problems. It has broader issues in terms of looking at the quality of the result. And then within education and training, I think it's very much about how well the student and trainee gains the knowledge and the skills and the attitudes. You know, there's a common myth that animal experiments are somehow the real thing, but this is not true. The real thing is how effectively you gain knowledge and skills and attitudes. And when I think there's that realization that this is all about, in education and training, the process of teaching objectives and how they're met, then you can start questioning traditional, conventional approaches and think, okay, what are we really trying to achieve here? We're trying to achieve this objective and that objective, which might involve everything from the basic life science philosophy of critical thinking and emotional and ethical literacy, because ethical decisions are going to be made in the professions all the time, and it's important we don't have desensitized students going into healthcare or animal healthcare. But it's also about how well that knowledge is retained, how well those skills are acquired and retained. And the alternatives, because it involves people thinking about what they're trying to achieve, thinking about the objectives, researching the many, many different methods developed by universities, the teachers themselves, and by companies, and looking at the best ways, all that collective knowledge and skill from people who've been teaching anatomy and physiology and surgery, in some cases for decades. Once you start looking at those different methods, start implementing them in what's most appropriate to your specific course, and many of these courses are the same across the world, then you can start meeting those objectives in a more effective way. And the graduates that then leave education to go into the profession, or go, which might be research or might be general practice working within a clinic, those students, the trainees, are going to be much better equipped for working with human patients, working with animal patients, contributing to society as well-rounded individuals who haven't been disturbed and desensitized by harmful animal use, as well as not having harmed animals in their education and training. So it's very important, I think, that we recognize the many social and even economic benefits of using alternatives, because it costs money to be buying animals, capturing them from the wild, sometimes endangered animals, breeding them and killing them and keeping them and then disposing of them. It costs money. The alternatives in general cost less. The most advanced computer simulation, which is another very big area of alternatives, the virtual dissection, the virtual laboratory, the virtual reality for surgical training. The most expensive, virtual reality, might be unaffordable by some institutes, some universities, but prices are always going down with new technology. So in general, alternatives cost less and they're more effective in terms of dealing with ever-growing class sizes and dealing with passing on that knowledge and skills from the teacher in a much more effective way. So it's really a multiple benefit. It's about thinking of curricular design. What are you trying to achieve? What are the best methods to do that? And then seeing that you get benefit, of course, to the animals not being used or benefiting from student interactions, and able to learn in a more effective way. The teachers benefit because they can pass on their knowledge and skills more effectively. The professions benefit because better trained people will be entering them. And society as a whole will benefit as well. So it's a multiple positive impact compared to the multiple negative impact of harmful animal use. And it's a similar issue when it comes to research and testing. On the economic level, in all areas, you have an opportunity for local economic development by the production and implementation of these new and innovative methods. There's more money, of course, within research and testing, which also helps explain part of the resistance to change, for example, from animal breeders. But once the people recognize, I think, that the objective of ensuring consumer safety with drug testing can be met more effectively with the alternatives, then the process of replacement can happen even faster. And certainly within testing, that process has already begun, because you can get a direct method, alternative method that can directly replace a specific test. The same with education and training. A lot of really good progress because a specific practical class can be replaced by a specific alternative. Research is a bit harder because it's so open-ended. I want to find out about this. I want to do what I want, and the funds might be there. But in general, there's very, very good news in terms of the potential for replacement and the positive impact right across society and, of course, within nature itself.
You've alluded to the fact that animal testing is required by some governments, despite it no longer being the most current or the most effective model for that particular purpose, as well as opposition from breeders who profit off of selling animals to laboratories. What other obstacles are there to non-animal methods and models becoming mainstream?
Within testing, yes. I mean, you've got the whole challenge of very large companies with a lot of economic power, pharmaceutical companies, often more power and money than some countries. And there's a great inertia sometimes from such large institutions, and that comes from a number of different places. You have just the fact that they're huge, and change can sometimes take some time. But you've also got the fact that these companies are developing drugs for profit. That's not to say that none of them could be useful for people, but there are broader issues behind disease, behind problems within society that need to be addressed as well. Fresh water, for example. Lots of people die because they don't have fresh water. So the economic system, which can lead to problems with health, is something that also we need to be challenging. Companies have a huge amount of money; they could be doing more, but they're not going to invest in traditional, natural healing approaches within a country, or help with fresh water or better food or better work. That's not their focus. If we can get some change happening in all those areas as well, then the need for such drugs and the power that we give to those companies can be reduced. So there are broader issues. There's also the issue of patent law, of course, and companies not sharing data, as I mentioned before, of the sometimes very poor science within certain tests, the poor statistics that mean there's a lot of tests are just not good enough. That's not valid within research and testing. The data or the results from tests that's negative, that is not published, so people can't learn from mistakes. The many times that the same experiments are repeated across companies and across countries. There's a huge amount of waste of animal life and time and money because of the fact that these results aren't being shared, and because of the context of a corporate capitalist culture, where we don't have an opportunity to be sharing, or a willingness to be sharing data and sort of working collectively for drug development. It may be that within the field of developing a vaccine for COVID-19, that there will be more sharing happening. We don't know. And because of the need for rapid development of a vaccine, there may also be interest, well, there is already interest in the non-animal methods, in the alternatives, because they're so much more efficient, including in terms of time and money, as well as the productivity. So there's a lot of different reasons really why things can sometimes be very slow. But I think increasingly people are realizing that even from a scientific perspective, the alternatives are better. And once people start sort of focusing on what really needs to be achieved and what are the best methods, and get exposed to them, there's a lot of training in these methods so people can see how they can be implemented. And some of that's being organized by the same companies because they also want to make money faster and not put in such a large amount of money over a decade for the development of their drug. So there is some really good progress. And sometimes it's just a question, I think, of a critical mass being reached before the change starts happening. But it feels that we're on a cusp of that now already, certainly within education and training, which is my main field. But even within testing, people are beginning to realize that, yes, leaving aside ethics or the environmental impact or anything else, actually, this is better science.
You already partly answered my last question, but regarding the COVID-19 pandemic and its implications for the use of animals in science, on the one hand, in the race for a vaccine, there have been many researchers who've actually skipped the standard animal testing in order to go straight to humans, or are using other alternatives to speed up the process. And you also have, with universities switching by necessity to online classes, I would presume that you have the use now of many of these virtual and video-based methods of learning about animal anatomy, physiology through simulations rather than hands-on. But on the other hand, you've also had the expansion of animal labs in some places. You've had a race to identify new species of animal that might be a better model for COVID-19 research. So all in all, in the wake of the pandemic, do you believe that it's more likely to make animal research obsolete, or will it further entrench the use of animals in science?
I think it's really difficult to say. I think we have to see how things pan out. I think that the fact that some work is being done using alternatives only, and remember, for many people, alternatives are just better methods. They may not even use the word alternatives. This is better science or better education and training in the other area. So I think the fact that there is that interest and there is that practice now will certainly influence positively the growth of these methods, new methods, as well as the implementation and the more wide take-up of such methods. Often it's a question of, I think, seeing things in practice before people realize it can be done. Some people are visionaries, they can imagine how things could or should be done. Other people like to see someone else having done it first. And once that is the case, then I think people will it makes it a little bit easier for many people to accept it. So I think the fact that there will be those different methods and they will be reported is certainly going to help make that approach more permanent. However, there is still a lot of inertia concerning animal experimentation. It's been a method used for decades. There's been developments within genetics, within other areas where new ways of using animals in experiments have been developed and spread. It's a big challenge. It certainly is a big challenge, particularly within research, less so perhaps within testing and education and training. But increasingly people are recognizing, I think, that because of the advantages of these methods and where they can see those advantages, there's really no point in continuing the older methods. There's also a sort of economic argument for carrying on the same way. You've got your lab set up and so on, and you have to invest in new equipment for new alternative methods. But the cost is in almost all cases less using the alternative methods. So I think as well as the scientific advantages of the alternative methods within research and testing, companies are also realizing that the economic advantages are in their favor as well. And sometimes a crisis like this with COVID-19 is something that provides a shake-up for people to reassess things rather than just carrying on in the same way. You know, we've all been living in a very different ways, and that applies also to companies and even governments and how they work. So I think once we've had that example of a different way of working, that can also sort of help unstick us from unhealthy traditions, unhealthy conventions, and think about different ways of doing things. So all in all, I'm quite positive about the field of alternatives to animal experiments in terms of the better, innovative and humane ways that are being developed and implemented as we speak, but also the new impetus for finding drugs, finding vaccines in a more effective way, as well as their testing. I mean, the batch testing for vaccines involves a lot of animals being used, and there are efforts afoot to make sure that amount of animal testing within vaccine production and quality control is reduced massively. So even if 80 or 90% of animal use in certain fields can be reduced, that again is a major progress. And then we've got to work, of course, on that last 10% as well. But yeah, I think overall it's quite a promising field, not just for animal protection and consumer safety, but all the broader issues in terms of, for example, the UN's 17 goals of sustainable development, from better quality education to a more equitable education and society, to broader ecological impact that can be positive instead of negative, and all the impact in terms of healthcare and health of the population as well.
Well, that's an excellent ending point, since this interview has been conducted by the Animal Issues Cluster of the United Nations NGO Major Group in connection with the High Level Political Forum, which is mainly discussing the SDGs. So thank you for touching on those in your last answer. It's been a fascinating interview. Thank you so much for your time.
Thank you too. Bye-bye.